sometime in the future, a space probe will plunge into a tunnel in space and time. One day, our universe will cool and die. Our only escape may be to risk a flight into a different universe. Perhaps the greatest question facing the human race is to discover where we came from and to find out what is our ultimate fate.
Every culture, every age has asked that question and tried to answer it.
It's one of the greatest adventures of the human mind to find out where we came from, where we are, and of course, in the end, where we're going.
Astronomy provides the basic information that each person needs to understand where he or she came from and where the human race is going.
Now, at the dawn of a new millennium, we are on the threshold of understanding how our universe began and how it will end. Cosmologists around the world are trying to unlock the origin and destiny of everything we see around us. One of this elite group is Bob Kirshner. He's on a journey to Cerro Tololo in Chile to measure if there's enough gravity to hold the universe together.
We've known for a long time that the universe is expanding and coasting along since the Big Bang. One of the questions has been how much gravity has been slowing down the expansion of the universe. Just like when you drive a car up a hill, you can slow down if you don't apply power because gravity's pulling back on you. We think that the expanding universe would be slowed down by the gravity, by all the stuff that's in the universe. One of the interesting things is that we've been able to do some work to try to measure that, and we found a surprising result. Not the one that we expected to find, but one that really turns the whole problem on its head.
Kirshner's team may have discovered answers that seal the fate of our universe. They've discovered that it's not just expanding, it's speeding up. Cosmologists now realize that to understand what the future may hold, they first have to unravel what happened at the beginning of the universe, at the start of time itself. In our daily lives, time is constant and dependable. It's almost impossible for us to imagine, but before the creation of the universe, there was no time.
We can trace back cosmic history to a stage when everything was very dense, very compressed, very hot. But the further we go back, conditions were so extreme that we can't really rely on any of our common sense intuitions. We can say that time, in the sense we understand it, didn't really exist before that.
So when did the clock start ticking? 12 billion years ago, there was absolutely nothing. No matter, no space, no time. We may never know how or why it happened, but a seething mass of energy smaller than an atom grew from nothing. You're inside the Big Bang, the birth of our universe, a violent fireball of unimaginable heat. For England's astronomer royal Martin Rees, understanding the Big Bang is the key to the universe.
Something that was literally originally only the size of a single atom or smaller, expanded to be large enough to encompass everything in our present universe.
Only the minutest fraction of a second had passed. But all of this was puny compared to what was about to happen. Propelled by a new surge of internal energy, the universe suddenly entered an incredible period of inflation. It expanded 100 trillion times to the size of a grapefruit. Einstein's famous equation, E equals mc squared, told us that energy and mass were interchangeable. It gave us the knowledge to build weapons of mass destruction and the knowledge to understand how our universe was born. When a nuclear bomb explodes, a tiny amount of matter is completely annihilated and converted into energy. But in the Big Bang, the exact opposite happened. Pure energy was converted into matter. Approaching a millionth of a second old, the universe was brimming with energy, so intense that it was spontaneously converted into lumps of matter, and its arch-rival, antimatter. A titanic battle ensued. Subatomic particles annihilated each other, blow for blow, particle for particle. When matter and antimatter meet, they mutually destruct. This is the most powerful release of energy known.
If our universe started off with equal amounts of matter and antimatter, all the atoms would annihilate with anti-atoms, and we'd end up with a universe consisting just of heat and radiation, but nothing from which we and the stars could have been made.
But somewhere in this tiny blazing inferno, the process was slightly imperfect. There was more matter than antimatter. At the end of the battle, matter had won, and the universe was far from empty. Every time a particle of antimatter had been annihilated, the energy was converted into radiation. And that radiation is right before our very eyes. Don't adjust your set. Hidden in the interference on a badly tuned TV set is the energy signal left from the first second of the universe. The discovery of the Big Bang was one of the greatest scientific discoveries of all time, even though it was an accident. This is the horn antenna at the Bell Research Labs in New Jersey. Its unusual funnel shape was designed to collect faint radio waves from early communication satellites. It was being used for an entirely different experiment when it detected something truly remarkable, a discovery that would win 2 American scientists the Nobel Prize.
When I visit the horn antenna, I'm always reminded of the days back in the 60s when Arno and I were using it seriously. You know, it's amazing to think about, just doing your experiment and discovering the beginning of the universe. But there it is.
In 1964, Bob Wilson and his colleague Arno Penzias were using the horn antenna to search for natural radio emissions from our own galaxy. But as soon as they switched their giant earpiece on, it started humming. It was picking up weak but constant background interference. Wilson and Penzias had no idea where the signal was coming from. At first, they suspected nearby New York, but when they ruled that out, their suspicions turned on the local bird population.
There were a pair of pigeons living in the antenna. Once a week, we'd come up and disturb them. They'd fly away, but the next day when we were gone, they'd come back. So the inside of the horn was covered with white pigeon droppings. We got up in the horn reflector with a broom and swept it all out.
With the pigeons evicted, the two scientists were disappointed to find the interference was still there.
We looked in various directions. Sometimes we looked at specific objects, other times we looked at random parts of the sky, and every time we did that, we saw the same level, the same amount of excess noise, that it was the same in all directions.
They began to realize that it could have a more dramatic origin. What Wilson and Penzias had stumbled across was a background of microwave radiation, a faint afterglow of the battle that defeated antimatter 12 billion years before.
The microwave background comes from the initial very dense and hot stage of the universe. And as the universe expands, the radiation expands with it. And just like anything else that expands, it tends to cool off. It came from the early stages of the universe, and it's just out there. If you go outside, it'll hit you on the head. You won't notice it because it's so weak. It's at such a low level that it's almost undetectable.
Every television set on Earth can detect the radiation from the Big Bang. Antimatter had been defeated, and the universe was still only a second old. Over the next 3 minutes, the explosions created the kind of matter we would recognize today: hydrogen and helium. It was still too early for the universe to shine. In the dark ages that followed the Big Bang, these elements would combine together and provide the building blocks of the first generation of stars and galaxies. The atoms created 12 billion years ago are still with us today. Every time you take a sip of water, you're swallowing hydrogen atoms that were created at the very beginning of the universe. Most of the atoms in our bodies were created in the first moments of the Big Bang.
We tend to often dissociate ourselves from the universe. We tend to think of asking questions about it versus us. But of course, that's not really true. We're a part of the universe. And when we ask about the origin and evolution of the universe itself, we're really asking questions about the origin and evolution of ourselves.
Since the Big Bang, the universe has continued to grow and expand. To understand just how big it has grown, we need to take an imaginary spaceship ride from the Earth to the edge of the visible universe. Our nearest neighbor is the Moon, just 250,000 miles away. At the center of our solar system, 93 million miles away, is our Sun. After crossing the center of our solar system, we continue our flight beyond the orbit of the Earth. The next planet out is Mars. Beyond the orbit of Mars is the asteroid belt. A billion miles away is the giant outer planet Saturn, almost 1,000 times the size of Earth. As we leave the solar system, we would pass one of our earliest interplanetary explorers, Voyager 1, launched in 1977 and traveling at a mere 40,000 miles per hour. Proxima Centauri and Alpha Centauri, A and B, our nearest stars, are 25 million miles away. Our solar system sits in the quiet suburbs of a spiral galaxy, the Milky Way, a star city containing over 100 billion stars. Every star we can see in the night sky lies within our own galaxy. This is deep space. Out beyond the Milky Way, 10 million miles from Earth, is the next spiral galaxy, Andromeda. Even traveling at the speed of light, it would take 2 million years to reach here. Andromeda and the Milky Way form part of a small cluster of galaxies called the Local Group. But stretching out way beyond the Local Group are much greater clusters of galaxies. If it were possible to travel fast enough for long enough and reach the edge of the known universe, this is what we would see. Uneven clusters of galaxies, a pattern that was predetermined in the very first second of the Big Bang. This is as far as our spaceship can take us. We are now 50 billion trillion miles from Earth. This is where science ends and speculation begins. Astronomers may never see what lies beyond here. This is where the secrets of the universe are hidden. For centuries, astronomers have been trying to locate our exact position by looking further and further across the vast expanses of deep space. For 400 years since Galileo first pointed his telescope at the sky, astronomers have not only been looking across the far reaches of space, but back in time. Because the light from distant objects takes so long to reach us, every telescope is a time machine. Even traveling at an unbelievable 186,000 miles per second, light takes a long time to cross space. Light reflected off the surface of the moon is already over a second old by the time it reaches us on Earth. Look up at Saturn, and you're seeing it as it was 1.5 hours ago. And we see Andromeda as it was when the first humans walked the Earth. Its light has been traveling across space for over 2 million years. Here at the Lick Observatory, Sandra Faber spent her early career unraveling the mysteries of the most distant galaxies.
The biggest telescopes on Earth now are taking us back billions of years into the past, 90% of the way back to the beginning of the universe.
View light from the furthest visible galaxies, and you're seeing them as they were over 11 billion years ago.
A galaxy is really like a city of stars. Just as there are billions of people on Earth or millions of people in a city, there are hundreds of billions of stars in a typical galaxy.
The universe contains over 100 billion galaxies. Like giant hurricanes in space, their resident stars spin around a giant central core. To see into the heart of the most distant galaxies would require a very special telescope. In 1990, the launch of the Hubble Space Telescope promised astronomers a view of the early universe they had only dared dream of. High above the Earth's atmosphere, this billion-dollar looking glass would have a totally clear view of the most distant galaxies. But the dream turned into a nightmare. Soon after it was launched, they discovered that the mirror was misshapen. It saw everything out of focus. One of the repairmen sent up to fix the stricken telescope was astronaut Jeff Hoffman.
It was unbelievably embarrassing for NASA and for the astronomical community. I mean, I had astronomer friends who that summer when they were on holiday and people asked, well, you know, what do you do for a living? They didn't even want to say I'm an astronomer because the first thing everybody would say, oh, the Hubble telescope, ha ha ha. You know, it was a big joke.
First, the crew of the rescue mission had to capture the crippled telescope.
Hello, Jeff?
Then execute a repair mission unprecedented in the history of space flight. Spread over 5 days of spacewalks, they repaired the faulty optics. The replacement parts fitted perfectly. The problems came when Hoffman attempted to close the huge access doors.
Lo and behold, they did not close. And I worked, I went up to the top of the doors, I went to the bottom of the doors. But what we figured out was that we could use an extra tool which had a little strap and wrap that around some bolts to gradually winch the door close. We ended up spending over 8 hours outside, which is the second longest spacewalk that's ever been done.
At one point in the mission, they even had to dump a damaged solar panel overboard. With all the repairs completed, the cosmological community held its collective breath to see if the most expensive telescope ever built would finally deliver what its designers originally promised. This is what Hubble saw. The images they received were beyond anyone's wildest imagination. Free from the distortion of the Earth's atmosphere, images captured by the Space Telescope left even the most hardened of cosmologists in awe. Hubble captured the final moments of a star's life when it explodes and blows off layers of gas and dust. It also captured interstellar nurseries of newly born stars, each one as varied and unique as a human fingerprint. And dark pillars of cosmic dust more than 1 million miles long, ready to spawn a new generation of stars and planets. But Hubble's true moment of glory was still to come. The mission controllers pointed the telescope at a distant, empty patch of deep space and waited. Over a period of 10 days in 1995, emerging across the coldness of space, the Hubble Deep Field image revealed a tapestry of distant galaxies. This was the furthest back in space and time we had ever seen.
To point the telescope for hundreds of hours and let this light that has traveled for 10 billion years slowly dribble in and accumulate. When you see so far back and see so many galaxies and imagine that the sky is filled with them, billions of galaxies, that's like 10 galaxies for every person on Earth, something like 50 to 100 billion galaxies, and each one of them containing 50 to 100 billion stars, say. That's an enormous number of places where there might be planets and life and very interesting things going on in the universe.
Powerful computers have turned the real galaxies of the deep field image into a remarkable 3D journey to the edge of the universe. In the foreground are mature galaxies like our own. Further back in time are younger, energetic galaxies. But beyond here, the structures begin to thin out. This is as far as we can see. This is the edge of the visible universe, over 90% of the way back to the beginning of everything. Faint galaxies that were formed just 1 billion years after the Big Bang. Beyond these galaxies, we can see nothing. We're entering the universe's dark ages.
Sometime a few 100 million years after the Big Bang, this dark age must have ended when the first stars were born. And so the universe lit up for the first time, perhaps 500 million years after the Big Bang, and it's been lit by stars ever since.
The universe is so vast, some astronomers have decided to make a map of exactly where we are. Just as Galileo tried to make sense of our place in the heavens, here at Apache Point, New Mexico, a group of astronomers are trying to locate our position by constructing the biggest map that anyone has ever seen. Built specifically to map over 1 million galaxies, this is the home of the Sloan Sky Survey. Over a period of 5 years, astronomer Jim Gunn and his colleagues are about to start mapping our exact position in the universe.
We're in a galaxy, which is not a particularly remarkable galaxy, but this 3D picture that we will make of the nearby universe tells us how we fit into this vast scheme of things that is the universe, and I think will give us a much better idea of our place.
By systematically scanning the entire night sky from a site high above the desert floor, the results will be plotted not as a 2-dimensional route map, but a fully interactive 3-dimensional guide to the universe.
If you think about that from a kind of cinematic point of view, one could take this map very easily, put this map on a computer, and enable you to rotate the map, to fly through space, if you like, to look at our galaxy from outside, to look at the other galaxies around us from the other side, and take not only from any angle you want, but from any place in this map, and look out and see what it's like to be somewhere else in the universe than what we are, which is, of course, what you see in science fiction films all the time, but you will actually be able to do it with the galaxies that are there.
Jim Gunn's survey is an ambitious project, and it's only just beginning. This is how the final map may look. It's a computer simulation of superclusters of galaxies massed together in giant blobs. You are here. This would be the position of our planet, our solar system, and our own Milky Way. But on this scale, it would be impossible to see us or even any of our neighboring galaxies. This is a map of everything we can see. Everything in the universe, all the visible stars and galaxies, were born in the same furnace, the Big Bang. A ball of intense heat still cooling as it continues to expand. Cosmologists are not only confident that they have unearthed the universe's past, but that they can also predict its future. Space, like the surface of hot-blown glass, cools as it expands. Just as flecks of color embedded in the glass move further apart the more it stretches, so do the galaxies. Space is expanding in all directions at once. Modern cosmologists are now trying to measure if this expansion will continue forever. How will the universe end? The key to the future of the universe was discovered long before modern astronomers built their giant telescopes. Back in the 1660s, when Sir Isaac Newton had an encounter with a falling apple and discovered gravity. Newton formulated laws of physics which formed the basis of modern science.
He realized that the same force that takes an apple and pulls it down from a tree towards the Earth pulls the moon towards the Earth, and in fact pulls the Earth towards the sun and pulls the sun towards the center of our galaxy. But in fact, gravity is the weakest force in nature. If you wanted to show someone how weak gravity is, just take a friend to the top of a tall building and push them off. And it may take 12 stories for them to fall and gravity to accelerate them all the way down to the ground. But electricity and magnetism in a fraction of a second and a fraction of an inch will stop them. Because the reason you don't go through things is not that the atoms in your body hit the atoms in the table, but rather it's the electric fields between those atoms that stop you. So electricity and magnetism stops you in a fraction of a second, even though it takes gravity all that time to accelerate you.
Gravity may be the weakest force, but it's the force that holds the planets and the stars together. After Newton, perhaps the greatest scientist and mathematician of all time was Albert Einstein. Einstein had been an unremarkable student, and his first job was as a clerk in the local patent office. His general theory of relativity, announced in 1915, explained for the very first time how everything within the universe interacts: space, matter, even time. His calculations told him that the stars and galaxies should exert a gravitational pull on each other and should eventually collapse together in a catastrophic fireball. But they hadn't collapsed, so to make his equations work, he invented a special repulsive force. But it was a makeshift solution, and deep down, Einstein knew it. Then, a decade later, along came a man with the solution to Einstein's puzzle. Here, at the Mount Wilson Observatory in California, Edwin Hubble took the first steps towards forecasting the fate of our entire universe. Hubble was a World War I veteran and a brilliant lawyer. When he turned his renowned skills to astronomy, he came up with a remarkable discovery that would change the way we view the universe forever. He made the astronomical discovery of the century, that the universe was expanding. 75 years on, measuring the precise speed of that expansion is the job of astronomer Wendy Friedman.
What Hubble found was that almost all galaxies appear to be moving away from us. And this led to the idea that the universe is expanding. Here was evidence for the first time that the universe was actually in motion, that galaxies are moving apart.
Hubble's revelation stood the astronomical community's understanding of the cosmos on its head. He'd used the same technique that police forces around the world use today to catch speeding motorists. Hubble used the astronomical equivalent of a police radar. Instead of using radar signals, Hubble measured the light that came from distant galaxies. He knew that their color would be slightly altered if they were traveling towards or away from us.
If an object is moving away from us, then the light from that object will be shifted toward the red part of the spectrum. If an object is coming towards us, the light will be shifted toward the blue part of the spectrum.
By determining just how much the color had been changed, Hubble could work out how fast a galaxy was traveling. It's an effect known as the Doppler shift, and it applies to both light and radar. Hubble found that all the light from all the galaxies was shifted towards the red part of the spectrum. They were traveling away from us at an incredible speed. Modern astronomers have calculated that we, along with all the contents of our own galaxy, are traveling away from the nearest cluster of galaxies at 1,000,000 miles an hour. By the end of this program, the whole universe will have expanded 1,000,000,000 miles in all directions. Cosmologists need to find out if there's enough matter in the universe for gravity to stop it expanding and flying apart.
There isn't enough matter, normal matter, to account for all the matter we can weigh in the universe. We can actually weigh the galaxy the same way we weigh the sun and the Earth, using Newton's laws. We watch the sun go around the galaxy, and we use gravity to determine how heavy the galaxy really is. And when we do that, we find there's a lot more out there than meets the eye.
Wondering if there is enough matter in the universe to stop it expanding is a prime concern of Professor Stephen Hawking. Born 300 years after Newton, Hawking now holds Newton's old job at Cambridge University. Hawking already knows that the visible galaxies do not produce enough gravity. He now suspects that the universe is full of invisible dark matter.
If the universe continues to expand forever, everything will burn out and decay. The amount of matter we observe in stars and gas clouds is only about 10% of what is required to stop the expansion of the universe and cause it to collapse again. However, there might be other dark matter that we can't see, but which can still affect the expansion of the universe.
Dark matter is everywhere. The reason we can't see it is because of its size. Particles of dark matter are so tiny they can pass through anything. Neil Spooner and a dedicated band of astrophysicists are attempting to trap dark matter particles called WIMPs, weakly interacting massive particles, a mile underground at Bulby Mine in England.
It just makes up so much matter, so much of the universe. It's at least 90% and probably 99%. If it wasn't for this material, our galaxies would just fly apart. We believe that dark matter is composed of elementary particles that arose in the Big Bang, and they're around us all the time and they're passing through us all the time.
Neil Spooner and his team feel sure that any particles that could penetrate through 5,000 feet of solid rock would be dark matter. The team are attempting to record collisions between particles of dark matter and the atoms in a light-emitting crystal. But it's a long vigil that requires an unusual level of patience.
Occasionally, like about once a day, you might get one interaction. In other words, the particle comes in, strikes an atom, it recoils, and it produces a little burst of light, ordinary visible light, which we can detect with our instruments and then amplify and record into our computers.
It will take years, but if their equipment successfully detects dark matter, Spooner's team will have discovered the invisible 90% of our universe. But this may not be enough. there may still be too little gravity to stop the universe expanding for eternity.
It could be that the universe will basically expand forever and simply dissipate, and eventually will end up with if you like, a soup of rather boring atoms and dark matter diffused around, and it'll be a sort of slow death and on into infinity, and that'll be it.
For some, the challenge of predicting the fate of our universe is compulsive. Their passion for cosmology often turns into a lifelong obsession.
There are a lot of people engaged in trying to find out what the universe is, and I think it's mostly the same kind of curiosity that kids have when they're 6 years old or 8 years old. It seems to get beaten out of them in school, but we're sort of the ones that, I don't know, the schools didn't affect or something like that. We're still asking those same questions and still trying to get answers to them.
Here at Cerro Tololo, cosmologists have made a startling new discovery. Bob Kirshner believes that dark matter may not be holding the universe together at all. They're forecasting how the universe will end by observing one of the most violent cosmic events, stars that explode in distant galaxies with unbelievable ferocity when they reach the end of their life. Supernovae. From the brightness of these explosions, Kirshner and his team can tell if a galaxy is near or far away. They measure the distant supernovae as markers to help them work out how fast the universe is expanding.
This is a very sensitive system that we're using. It has an electronic detector, and of course it's connected to a gigantic telescope. It lets you see objects which are about 100 million times fainter than you can see with your dark adapted eye.
Like Edwin Hubble, they're using the light from distant galaxies to get an accurate fix on the universe's rate of expansion. They thought they would be measuring how much the gravitational pull from dark matter was slowing the expansion rate down. But what they have found has stunned the cosmological community.
At the location. Well, maybe it's the other galaxy.
Rather than slowing down, the universe is speeding up. The galaxies are moving apart faster than ever before. Dark matter is not powerful enough.
See, but it looks to me like there's still something there at the location that was there, right there. Yep.
Scientists now believe that the universe will not collapse in a catastrophic fireball, nor will it coast on serenely. Instead, its contents will speed apart faster and faster until lost in the vast blackness of space.
So if the picture that is coming from the supernovae is really right, the universe will expand forever. In fact, faster and faster on into the future. Now, this is really not anything to worry about, even though it is a kind of a bleak future of an empty, cold, dark universe.
What Kirshner may have discovered is a remnant of the original Big Bang. The inflation that started in the very first second of the universe is taking off again.
What makes cosmology at the end of the 20th century so exciting is that, in fact, we understand that the largest things in the universe are really determined by the smallest things in the universe, that there's this connection because at the very early Big Bang, the fundamental forces governing the microscopic structure of matter really determined the structures we see today on scales as large as galaxies and superclusters.
The shape of our universe, everything we see around us, was determined when the universe was smaller than an atom and only a fraction of a second old. Our universe is cooling and dying. In 1 billion years from now, our first unmanned spacecraft like Voyager 1 will leave the Milky Way and drift unhindered through the universe. As the universe reaches middle age, even the longest-lived stars will start to burn out.
Our sun has about 5 billion years of life left, and very few stars will still be shining 10 billion years from now. The dead stars will still orbit around the center of the galaxy, but their collisions will gradually cause most of them to fall into a giant black hole at the center.
Suppose we look ahead to when the universe is 100 billion years old. Then it would be a rather dull and dark place, because all but the faintest and most slow-burning stars will have died, so the universe will not only disperse, but all the galaxies will get fainter.
As the universe expands with age, gravity will lose its precarious grip. If you could be there to witness it, you would see absolutely nothing. Is there anything the human race could do to flee from such a dark fate? Could we escape into another dimension, into another universe?
The best ideas that people have come up with do suggest that maybe our Big Bang was not the only one, and that the inflation which led to our universe may have happened elsewhere, maybe an infinite number of times, in some grand eternal cosmos.
If other universes do exist, could we ever find a way of traveling into one?
It's incredibly interesting that there's a lot more we don't know about the universe than we do, in spite of all we've learned up to date. And therefore, some of the wild ideas from science fiction, including things like even wormholes, might or might not be possible. We just don't know at this point.
Wormholes are another prediction of Einstein's theories. Here, space is so twisted that it forms a tunnel from one universe to another. Even if these hypothetical holes in space and time do exist, entering a neighboring universe could be unwise. Travel into one where the laws of physics are even slightly different from our own, and you'd cease to exist at all.
Even though we have very small brains and we lead very brief lives and so on, the fact is we're able to understand where we are, and because we can use instruments like the big telescopes, the physics that we learn on the surface of the Earth, and the ideas that people have had over the last few centuries to build up a coherent picture. And I think we should be proud of that. We've done pretty well.
I feel it's been a great privilege and a huge amount of luck to be present to witness an important science like cosmology hit its peak.
In some way, creatures like us, and there probably are many, are the consciousness or the intelligence of the universe. It's almost as if the universe invented a way to know itself.
After centuries of gazing at the heavens, scientists now know that everything in our universe was born 12 billion years ago. Before the Big Bang, there was nothing. This violent explosion gave birth to everything we can see. Countless galaxies, stars and planets, even life itself. nearest star, the Sun, will die, swelling and becoming a red giant. The heat will be so intense, the oceans will boil. Our planet will be scorched beyond recognition. The crust will melt. The surface will become an ocean of molten rock. All life will end in the ultimate Armageddon. Our universe is alive with the shimmering of countless stars. But our vision from beneath the Earth's protective atmosphere shields us from the real dangers. Every single star will eventually die. Many will spew deadly radiation and particles across the galaxy. Bob Kirshner is a Harvard professor with a passion for the stars. He spent a lifetime studying them, from their cradle to their grave.
I remember as a kid going out and seeing the stars at night, and I'd lie on the snow, I remember, with a flashlight and a star map, and try to dope out what things were where in the sky. And my mother used to call out the back door, and she'd say, "Bobby, come in, get off that snow."
Today, instead of lying in the snow, Kirshner comes to Kitt Peak Observatory.
Kitt Peak is at about 7,000 feet, so it's not a particularly high mountain, but it is considerably above the valley floor. So it's a good site for astronomy. Also, the weather is very good down here in Arizona, so we get a lot of clear nights.
He has a date with the night sky to look for one of the most dramatic and beautiful events in the universe, the birth of a new star. As the sun sets over the Arizona desert, the observatories open for work. This mountaintop gives astronomers an unrivaled view of the sky, high above the clouds and obscuring lower atmosphere. Kirshner is looking for giant clouds of gas inside our galaxy, the Milky Way, that may give birth to new stars.
Okay, we're ready. Let's go to the first one now.
All right.
There are catalogs of regions where stars have been forming or where there are big clouds of gas that people have compiled over the years. And so by looking at some of these things from the catalog, we can begin to investigate individual areas where there really are stars forming and where we can look deep into them to see what's going on.
With their high-power telescopes, Kirshner and his colleagues have been peering into enormous gas clouds inside our own galaxy. This is the Lagoon Nebula, an interstellar nursery, which is giving birth to hundreds of new stars. The clouds are mostly made of hydrogen, the most abundant element in the universe. They are so dense they begin spiraling inwards under their own gravity. The matter collects and begins to form a fledgling star, a protostar. With a disk of gas and dust falling inwards, it spins faster and faster. This was probably how our sun and the solar system was born.
After a while, the material that is in orbit around the protostar starts bumping into itself, and so it builds up bigger particles out of smaller ones, eventually makes dust and makes gravel, and then very quickly, probably, builds up things as big as planets.
This is the moment of birth of a new star, with a new sun spawning a disk of orbiting planets.
The star shrinks down more and more until it becomes hot enough and dense enough for the nuclear reactions in the center to get going that turn it from being a glowing ball of gas into a real star, something that has a nuclear fire down in the center.
The same nuclear reactions that take place in a hydrogen bomb, converting hydrogen into helium, produces the energy that causes stars to shine. When the nuclear fires ignite, a new star is born. Since the birth of our solar system, the closest and most familiar star of all, our sun, has bathed our planet in heat and light. At the heart of the sun, 600 million tons of hydrogen are converted into helium every second in a nuclear reaction that fired up 4.5 billion years ago. For generations, the only way astronomers could study the sun's fiery atmosphere was during a total solar eclipse. For a few fleeting minutes, the sun drops its guard, allowing us a glimpse of its awesome power. Francisco Diego, a professional eclipse chaser, saw his first eclipse as a teenager in Mexico. It began a lifelong fascination with the sun.
The total solar eclipse is an event that, when you see it, you will never forget. The day of the eclipse is very special. When you look at the sun, you see this beautiful, complete, perfect disk. But the day of the eclipse, exactly at the time that has been predicted for many, many years in advance, you see how the moon starts eating into it.
At total eclipse, the moon will align itself perfectly between the sun and the Earth. The moon is 400 times closer to the Earth than the sun, and by extraordinary cosmological coincidence, it's also exactly 400 times smaller. Diego and his astronomical colleagues will travel anywhere on Earth to study this rare celestial event. Each eclipse will last just a few precious minutes.
The temperature starts dropping, and it drops up to about 10 or 15 degrees in some cases. It's very noticeable. You feel this wind, this atmosphere just agitating, and it is very, very tense moment. Then you look at the west, because the shadow of the moon is coming towards you very fast at 3,000 kilometers per hour. The landscape loses its colors.
A 100-mile-wide shadow will pass over the surface of the Earth. The brightness of the midday sun will slowly turn to night.
The sky gets so dark that the corona, which is very faint, is now visible. It really flourishes. It's like a flower, a white flower that opens its petals in the sky.
This is the sun's corona, a glowing atmosphere normally obscured by the intense glare. It burns at over 1 million degrees. Giant prominences erupt from its surface. They could swallow the Earth dozens of times over. Like giant fingers, they stretch for millions of miles into the vacuum of space. But for solar astronomers like Diego, a total eclipse is over all too soon. After just a few minutes, the alignment is lost. The sun's brilliant light bursts out from behind the moon, a magical sight that eclipse watchers have named the Diamond Ring.
When you finish looking at the diamond ring and you see the shadow of the moon rushing away from you now towards the east, then you see that was it. Those 2 or 3 minutes are gone. You have been waiting for that for years, and suddenly it is gone. You feel like a vacuum, and you say, this is not enough. I want more.
As the sun breaks out from behind the moon, once again the Earth is bathed in its light. We rely on the sun's constant energy to breathe life into our planet. It gives us free energy. Its heat evaporates water to produce the clouds and rain. The slightest change in its behavior could put the world and even the human race at risk. To keep a constant vigil on the sun's enormous power from above the Earth's shimmering atmosphere, a new satellite, SOHO, was designed and built by NASA and the European Space Agency. Launched in 1995, SOHO was to promise a breakthrough in sun observations and give astronomers a front-row view of our nearest star. Douglas Goff, a solar astronomer at Cambridge University, was one of the members of the SOHO team.
The satellite has gone to a position between the Earth and the Sun, where the gravitational pull of the two cancels. So it sits there looking at the Sun continuously and beaming back the information to Earth.
The images it beamed back were beyond their wildest dreams. The sun's raging surface is a turbulent world, its eruptions ripped and torn by enormous magnetic fields. Soho revealed that, like the Earth, the sun has weather. Gigantic solar tornadoes twist through its atmosphere. And gigantic shockwaves rip across its surface. The surface of the sun is heaving. Every 5 minutes, the entire star breathes in and out. Our sun is pulsating. This is the real sound of it vibrating, speeded up thousands of times.
The outside of the sun is in a very dynamical, turbulent motion, just like the turbulence behind the back of a jet engine. The jet engine creates a lot of noise. Similarly, this motion creates a lot of noise inside the sun, which reverberates around and makes the sun sing. And by listening to those tones, we can learn about the structure of the sun inside.
Below its churning surface, there's a nuclear furnace that will burn for billions of years. From its nuclear heart, trillions and trillions of tiny particles of radiation, photons, make their arduous journey from the core to the surface. The photons collide with super-dense gas. They take so many hits that a trip that should take just a few seconds takes millions of years. But after the photons escape from the surface as light, they take only 8 1/3 minutes to travel from the sun to the Earth. Every summer, millions of people go out of their way to worship their local star. Even 93 million miles away, we can feel the sun's enormous destructive power. But not all of us are naturally protected against the sun's lethal rays. Fair-skinned people have weak defenses. The result is sunburn from the sun's deadly ultraviolet radiation. This anti-burn patrol is on the lookout for unprotected bathers. The greater the exposure to the sun, the greater the risk of getting skin cancer, especially deadly malignant melanomas. Greater dangers are whipped up when the sun's surface is twisted and contorted by powerful magnetic fields. These fields can puncture the surface and create dark areas called sunspots. Each one is big enough to swallow the entire Earth, and their presence is a warning. The magnetic disturbances cause enormous eruptions, blasting huge amounts of radiation and billions of tons of charged particles into space. Every 11 years, the sunspots increase in number and size. A mass of intense energy can head our way, engulfing the entire Earth. When this happens, it's not just the sunbathers who need to head for cover. March 1989. The sun was about to give eastern Canada an early wake-up call. It was the height of the sun's 11-year cycle, the solar maximum. Out in space, a cloud of incandescent matter over 1 million miles long was heading straight for Earth. Night workers at the National Grid Control Center had no idea what was in store. At 2:45 in the morning, engineers noticed an enormous surge in their power system. When the cloud hit the Earth, it induced a massive surge of electricity inside the power cables. Engineers struggled to reduce the load, but in a matter of minutes, they'd lost control of the whole system. Power plants over 500,000 square miles of Quebec were swamped with excess current. Moments later, the whole grid blew. The city was plummeted into darkness. Power was lost to 8 million homes. Further north, the same cloud that had plunged Quebec into darkness was lighting up the night sky in a massive celestial fireworks display. This is the Aurora Borealis. Some of the particles from the cloud had become trapped inside the Earth's magnetic field. As they passed through the atmosphere, they reacted with the air. Like a giant neon light, the solar radiation lit up the night sky. Our sun is not the only star that threatens our existence. Space is filled with harmful particles and radiation. Traveling above the Earth's protective atmosphere is extremely dangerous. Despite the dangers of traveling above the atmosphere, our desire to conquer space is so great that we are prepared to risk the consequences. In 1969, Buzz Aldrin, Neil Armstrong, and Mike Collins began their historic 250,000-mile journey to the moon.
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made.
Celebrations ran high as Aldrin and Armstrong stepped onto the lunar surface for the first time. But behind the euphoria, the pair were keeping a secret from Mission Control in Houston. They'd seen more than just the dust of the moon's surface. It was only when they returned to Earth that Armstrong and Aldrin revealed their secret. They reported seeing strange white streaks of light flashing in their eyes. NASA decided to run tests on future missions to discover exactly what the light flashes might be. Astronaut Charlie Duke was their guinea pig. On board Apollo 16, he was asked to watch out for the mysterious flashes.
We're on our way to the moon, and all of a sudden I closed my eyes and I saw one. It was like the first one was like a flash bulb exploding inside your eye. It was very bright, very white, and I said, hey, I saw my first one. It was just this streak of light, very fast, and just as white as it could be, and very bright.
A young researcher, Larry Pinsky, was assigned to work with Duke and find out what was causing the flashes.
White streak in the right eye, upper center. Mark, light streak.
He recorded Duke's comments back in Houston and eventually realized the flashes could only be one thing.
Bottom to up, top. Mark, faint left, faint white dot in the left eye, extreme left.
Well, it turns out that they were seeing cosmic rays. They were seeing these elementary particles that permeate space, that penetrate the spacecraft and actually penetrate the body, and in this case, penetrate the eye.
We feeling good. Tony, how about an extension, you guys?
What Pinsky had worked out was that Duke and the other astronauts were seeing high-energy particles produced from one of the universe's most violent acts of destruction. When a massive star trillions of miles away explodes as a supernova. As a heavyweight star nears the end of its life, it incinerates all the fuel in its core. The heavier a star is, the more catastrophic its death. The core becomes unstable. It loses energy and starts a headlong collapse that for 1 second gives off as much energy as all the stars in all the galaxies in the universe.
Cosmic rays are actually particles. They're actually little pieces of matter. They are the nuclei of atoms. The atoms come from supernovae, and they're just the bare nucleus accelerated to very, very high velocities.
I'm sure they were there all the time, but the only time you'd ever notice them is when you sort of got quiet, closed your eyes, and thought about it, and then you'd see them going off.
Mark, faint white dot in the left eye, extreme left.
There wasn't any pain associated with it. It's just sort of like a very spectacular fireworks display going off inside your eyeball.
When the astronauts returned to Earth, Pinsky took a closer look at Duke's space helmet. He found hundreds of microscopic tracks where the cosmic rays had tunneled right through.
They are tremendously penetrating and do considerable damage to the molecular structure of whatever they pass through. And this is the reason why they're a hazard to people when they pass through you.
The thought occurred to me, you know, if I was out here maybe a couple of years, these little things burning a hole through my head might cause me some problems in the future, but we didn't worry about it, of course, on a short mission like we were on.
But if a supernova is too close, it won't be only astronauts who will be at risk. It could kill everything down here on Earth. Our galaxy is packed with over 100 billion stars, many of them near the end of their natural life. At least 1 or 2 supernovas explode in our galaxy every century. 2 young astronomers from Caltech have now come up with a new theory of life on Earth that has shaken our scientific beliefs. A theory that links the death of stars to mass extinctions on Earth.
The fossil record of the last 500 million years shows 5 or 6 huge extinction events. in which anywhere from 60 to 95% of species on Earth, dinosaurs, reptiles, etc., were wiped out. And so what Gadam and I really set out to do was to come up with some sort of model that would explain why the major extinctions happen when they do.
Eric Litch and Gautam Vasisht have calculated exactly when the Earth may have been close to ancient supernovas. The key to their model was understanding the rotation of the Milky Way. Like a giant spinning wheel, the Milky Way is circled by spiral arms packed with billions of stars.
Spiral arms are really disturbances that sweep through the disk of the galaxy, and gas and dust tends to accumulate along these disturbances.
Yeah, if you imagine looking at our galaxy face on, the spiral arms appear like swirls going out from the center to the outer edge, rather like the kind of whirlpool you see when water goes down a drain.
The spiral arms are where supernovas are most likely to explode. Our solar system passes in and out of the arms once every 50 million years.
We know the location of the spiral arms fairly well, so we could trace the orbit of the Earth back into time. The hope was to find a link between the times of occurrences, the extinctions, and the timing of the passage of the Earth through the spiral arms.
Their calculations revealed that the biggest mass extinctions correspond exactly with the dates when the Earth had passed through the spiral arms. If a supernova exploded nearby, the surface of the Earth would have been swamped by deadly radiation.
If the solar system happens to be passing through a spiral arm, your chances of encountering a supernova explosion at close enough range to do serious damage to the Earth are quite high. In fact, we estimated something like 50-50.
Understanding the mystery of just how massive stars die has taken astronomers centuries to unravel. Modern astronomers picked up their first clues from an unusual source during the Second World War in occupied Holland. Jan Duvendak, a scholar of ancient Chinese manuscripts, discovered a document written in China nearly 900 years earlier. It reported,
"On the 22nd day of the 7th moon of the first year of the period, Chiu-wei said, prostrating myself, I have observed the appearance of a guest star in the 5th moon in the eastern heavens in Taurus. It was visible by day, like Venus. Pointy rays shot out from it on all sides."
The account told of a bright star that had appeared in the heavens in the summer of 1054, which shone for 22 months and then disappeared. Duvendak realized the significance of his discovery. Through contacts in the Dutch underground, he smuggled a paper through enemy lines and across the Atlantic to astronomers in the United States. "20 years earlier, American astronomers had discovered that a distant cloud of gas called the Crab Nebula at the fringes of our galaxy was expanding. By working backwards, they had calculated that it had originated from a single point some 900 years earlier, exactly the time of the Chinese star. Astronomers believed that the Crab Nebula was the debris from an exploding star, a supernova. but at the time they had no proof. The Chinese star was so bright it could be seen in daylight, and for a time it was even possible to write by its light. What's more, the star had appeared in exactly the same part of the sky as the Crab Nebula. It clinched the argument. It had to be the remains of an exploding star. The blue glow of the Crab Nebula comes from escaping cosmic rays. The colored pincers are the remnants spewed out in the giant explosion. But for this star, the supernova explosion wasn't the end. Left behind was a strange corpse. Professor Anthony Hewish from Cambridge University discovered there was life beyond the grave for dead stars when he built an unusual telescope in the 1960s.
We started building in 1965. The thing was we wanted a large radio telescope which was very sensitive, but it had to be rather cheap. And I decided on this construction of a big dipole array. We all took our turns in hammering the posts into the ground and hanging up the wires and putting into the cables. It was just very much a team effort.
Over the next 2 years, Hewish and a small team of students built a jumble of wires and poles spread over a 4-acre site. This strange-looking telescope was to discover the weirdest object in the universe and win Hewish the Nobel Prize. The task of running it was the responsibility of then research student Jocelyn Bell.
Producing miles of chart paper, 96 feet of chart paper every day. And we kept scanning the sky over and over and over again. I ran it for 6 months and generated several miles of chart paper.
In August 1967, after just 1 month of operation, an unusual signal caught her eye.
As the pen ran over the chart paper, it went beep, 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 beep. Regular pulses, about 1 1/3 seconds apart.
It looks so artificial. It looks like an intelligent signal to begin with. And intelligent signals coming from outer space, what are they? Well, you make a joke and say perhaps somebody's talking to us in some kind of a code. So we call these things little green men, LGM. I mean, we didn't really believe it. On the other hand, it was a possibility you couldn't immediately ignore.
After months of analysis, Hewish and Bell came to an outstanding conclusion. Only a small, super-dense spinning object could be creating such a fast pulse. The only possibility was the collapsed core of a supernova, a neutron star. Here was the living corpse.
I really didn't know neutron stars existed until I started talking to people and said, look, can you tell me any sort of star that's smaller than 1,000 kilometers? And up came the answer, neutron stars, and maybe we're seeing the first one of them.
The pulses that come from one of these neutron stars come to us because, like a lighthouse, these stars are spinning, and they have a beam that's focused by the magnetic field of the star, and every time the beam sweeps across us, across our radio telescope, we pick up a pulse.
But for 1 year, there were literally hundreds of theories being published, and it was an absolutely open question. And I think it only became generally accepted after about 12 months that it had to be a neutron star.
The revelation triggered a wave of activity. Radio telescopes all over the world scanned the heavens looking for the mysterious pulses. Less than a year later, the giant Arecibo dish in Puerto Rico picked up a signal. It was coming from the heart of the Crab Nebula. They had found the ticking corpse at the center of the Chinese supernova. The spinning neutron star was not only giving off radio waves, amazingly, it was also visible. High-speed television pictures revealed it was flashing on and off 30 times a second. It was the most powerful object that anyone had ever photographed. Neutron stars are like nothing else in the universe. They're so dense, a thimbleful would weigh over 100 million tons.
Supposing you somehow manage to land on a neutron star, then you are experiencing phenomenal gravity. And the atmosphere, instead of being 5 miles thick, is about 5 millimeters thick. So if you stood on the neutron star, the atmosphere would be sloshing around between your toes.
But even a neutron star's phenomenal gravity is surpassed when a real super heavyweight star dies. When a star 100 times heavier than our sun switches off, it goes with a bang. While we see the outward explosion as a supernova, this masks the inward implosion. The core is collapsing into the most dangerous object in the universe. The density becomes so great in the center that gravity sucks in time and space itself from the outside universe. A darkness forms at the heart of the collapsing star. A black hole is born.
If you have a massive star, once the massive star has exhausted its nuclear fuel, which is keeping it hot and keeping it puffed up, gravity becomes so strong that it just overwhelms all pressure the material can provide, and the star goes imploding inward, and it's gone, forming a black hole.
Everyone has heard of black holes. No one has seen them or been near one. At the center of a black hole is a point called the singularity. Everything that has ever fallen into a black hole is destroyed, crushed into a pinpoint of infinite density and infinite smallness. Even space and time are squelched out of existence.
The singularity is a place where gravity is essentially infinitely strong. It's a place where matter gets destroyed. It's a place where space and time as we know them get destroyed.
At some time in the future, a spaceship from Earth will be sent into the jaws of the most elusive object in the universe. A spacecraft traveling towards a black hole wouldn't see the singularity hidden deep inside. It would only see the blackness around it. Its target has a gravitational pull that is so great, not even light can escape.
As the spaceship goes flying into the core of the black hole, I begin to feel myself being pulled from head to foot and squeezed from the sides. My body gives way, I die, the atoms of which I'm made give way, and all is destroyed in the singularity.
All that remains is a perfect sphere of absolute darkness, a gravitational ghost of the star that died. The perils of a black hole are thankfully remote. Even the nearest is over 5,000 light years from Earth. Our nemesis lies much closer to home. Like every star in the galaxy, our sun has a finite lifespan. One day, it will run out of fuel and scorch the planets. It's a terrible fate that astronomers have known for decades.
We expect that the sun will swell up in about 5 billion years, and it will become a red giant star. That's the beginning of the end for the sun.
In 5 billion years, our local star will have exhausted its fuel supply. Without fuel, the sun will die. In its death throes, the star that gave birth to life will swell and engulf the Earth and Moon. Nothing will survive.
The amount of energy we'd get from the sun would increase tremendously. The Earth would heat up, the oceans would boil, eventually the mountains would melt and evaporate. The Earth would be incinerated by our own friendly star, the sun.
The heat from this red giant will be so intense, the Earth will be scorched beyond recognition. The Earth's crust will melt. The surface will become an ocean of molten rock. Nothing will survive the ultimate catastrophe.
And that's the end of the story for the sun. It will cool off, and as time passes, the sun will become a dimmer and dimmer, cooler and cooler clinker of a leftover star.
The Earth, devoid of all life, will sit in the cold emptiness of space. As our sun's brilliance dies, somewhere in the galaxy, in an endless cycle of life and death, a new star will be born. Maybe it will spawn its own solar system, even a new planet like Earth, and a new place where life can flourish. We have blasted men and machines to our neighboring worlds, sent probes to the outer solar system, discovered volcanoes erupting on the surface of distant moons, visited worlds more diverse than we had ever imagined.
What pushes us to want to explore planets is a need to know. And the planets now, and for the last nearly 40 years, have been within our reach.
We have landed on Mars, walked on the moon. At the dawn of a new millennium, we're at the start of a new era of exploring the planets. $12 billion years ago, our universe was forged in the Big Bang. It created countless galaxies, the birthplace of stars and planets. Our own star, the Sun, and its system of 9 orbiting planets, was born over 7 billion years after the Big Bang. This man is about to take a trip into the depths of our solar system. Without even leaving the Earth's atmosphere, planetary astronomer Richard Terrell is on a journey to explore the origin of our planets. He's come here to the heart of the Mojave Desert, one of the driest and most barren places on Earth, to search for meteorites, rocks from outer space.
Meteorites are phenomenally important because they're really the only samples we have of what's out there, except for the moon rocks that we've collected. They're objects we can place in our laboratories. They can tell us what the raw ingredients were that formed the Earth and the planets.
Space is not as empty as we think. Each day, the Earth sweeps up over 20 tons of space debris. These are shooting stars, small lumps of rock captured by light-sensitive cameras as they burn up in the Earth's atmosphere. Usually, large meteorites break into many smaller fragments. They can land anywhere on Earth, but it's only when they land on an ice cap or a desert that we can find them. Meteorites are the builder's rubble from the greatest construction site of all time. They're fragments left over from when the planets were born.
The meteorites really tell a fantastic story. Most of the meteorites are incredibly old, dating back to the origin of the Earth and the Sun. They're really telling us the entire chemical and organic history of the material that formed the planets and give us a great deal of insight into our origins and the origin of life.
By radioactive dating of the minerals in these rocks, astronomers have been able to work out that the Earth and all the other planets were created 4.5 billion years ago. The solar system started life as interstellar gas and dust, a giant disk spinning inside the Milky Way. As gravity pulled the fine grains of dust together, a disk hundreds of billions of miles wide began to spin and collapse. At its heart, the material was so dense, nuclear fires ignited our sun. The heat of the new sun blew the lighter gases away to the edge of the disk, where it condensed to form the outer giant planets. At the center were small, heavy planets rich in iron. These new, young protoplanets were bombarded by the debris.
In the inner solar system, where we have 4 planets today, there were between 50 and 100 protoplanets, young planets, that ranged in size from about moon size to Mars size.
Our own planet was about to experience a traumatic birth. It lay directly in the path of another protoplanet.
And this is a body that's comparable in size to the Earth, so it would not be as if there was a small object in the sky. As it got close, it would literally fill the entire sky.
There was no escape. A collision was inevitable.
If this impact were to happen today, there would be no place to hide. This is truly a cataclysmic event.
The impact energy was so enormous, both protoplanets were melted. The liquid cooled, and the Earth was reborn. Orbiting around it was another new, smaller world, our moon. It gave us a target we could reach, a possible stepping stone from which to explore further into deep space. Without the proximity of our nearest neighbor, we may never have started to explore space. In 1961, President Kennedy used the moon to set the greatest challenge in history.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Even the astronauts of Apollo 11 believed there was only a 50-50 chance they would return safely from the moon.
We choose to go to the moon. We choose to go to the moon and do the other things, not because they are easy, but because they are hard.
To reach the moon, NASA created the most powerful rocket they'd ever built, the mighty Saturn V.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
The world held its collective breath as the 3 men set out on the most daring adventure of all time.
Houston, Apollo 11, if that is, gave us a magnificent ride. Roger, 11, we'll pass that on, and it certainly looks like you're well on your way now.
The astronauts traveled 240,000 miles in 4 days. From their tiny windows, they looked out on a world pockmarked by millions of impact craters.
You're go for landing, over. Roger, understand, go for landing.
To avoid landing on rough ground, they aimed for a large, flat plateau, known to generations of astronomers as the Sea of Tranquility.
Okay, engine stop. We copy it down, Eagle. Houston, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
The date was July the 20th, 1969. Man had taken his first step towards the planets. Over the next 3 years, 5 more Apollo missions landed on the surface of the moon. Only 12 men have walked there. The last man to stand on the moon was the commander of Apollo 17, Gene Cernan.
That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.
Just the fact that you are there. You are on another body in our universe that is different, distinctly different, separate from our Earth, makes it overpowering. You know, here I am where no man has ever been before. Nobody has ever walked where I'm walking. No one has ever seen the mountains and the valleys and the boulders that I've seen. That makes it beautiful. That makes it special.
The lunar surface is covered in fine powder. It's the legacy of billions of years of pulverizing impacts. Beneath the powder, most of the crust is made of ancient rocks formed when an ocean of liquid magma cooled over 4 billion years ago.
The bottom of the core is not smooth, it's very jaggedy and fragmental-like. Time proceeded, 3, 2, 1, ignition. Right away, Houston. Vector grid. Mags off.
Apollo had cost America $24 billion. The American public was tired of paying for expensive manned flights.
We were the last mission of Apollo, and I knew that I'd be the last man to have left my footprints on the surface of the moon. But I never believed, ever, that I'd be standing here over a quarter century later and still be the last man to have walked on a surface moon. I think in one sense it tells us what we have not done over the last 25 years as much as it tells us what we have done.
Four days after leaving the moon, Apollo 17 safely re-entered the Earth's atmosphere. This was the end of the Apollo program, the end of an era. Over a quarter of a century after the last astronaut left the moon, NASA launched an unmanned probe. In 1998, the Lunar Prospector probe was sent to detect any resources that might be useful if we ever wanted to return to the moon and build a permanent base. One of its tasks was to search for water by sniffing for hydrogen particles from a height of up to 100 miles above the lunar surface. Lunar Prospector spent 9 months orbiting the moon, scanning every square inch. Its search was not in vain. As it flew over the poles, it detected hydrogen atoms, probably from water frozen below the surface. Lunar Prospector had found a resource that could revolutionize space travel.
Ice is important because you can break ice into its component pieces. You can make ice into hydrogen and oxygen. And hydrogen and oxygen are the primary components of rocket fuel.
Most rockets are powered by liquid hydrogen and liquid oxygen. If we could mine ice from the lunar surface, we could turn it into rocket fuel and use the moon as a launch pad towards the planet.
If you would have the materials that you need in space already in space, you've saved a lot of money. So that makes the 10 billion tons of water worth trillions and trillions of dollars. And nations have gone to war for a lot less.
Lunar astronauts of the future could be mining engineers. The water ice that Lunar Prospector detected is most likely frozen underground in craters near the poles that lie in permanent darkness.
It allows you to use the moon as a filling station. You can stop at the moon, you can use the ice to make hydrogen and oxygen and refuel your rocket and basically go anywhere you want.
With this bonanza of cheap fuel, our descendants will be free to roam the solar system and search for the next planet that we might call home. At the end of its successful mission, Lunar Prospector was sent crashing into the lunar surface. When it struck, it was traveling at almost 4,000 miles an hour. The solar system is vast. There are 9 known planets. The giant outer planets orbit billions of miles out from the sun. The human race has evolved by taking risks, conquering new environments. But sending astronauts out here will take generations. The only way we can visit these planets in our lifetime is by sending robotic probes. Inside the asteroid belt are the 4 rocky terrestrial planets: Mars, our home, Earth, and inward towards the Sun are just 2 planets we could try and visit: Venus and Mercury. Mercury orbits just 36 million miles from the Sun. Inside, it's made of 70% iron, far more dense than the Earth or the Moon. In 1973, NASA sent Mariner 10 to photograph the surface of this harsh and remote world. The pictures it sent back revealed that, like the Moon, its surface was heavily cratered, battered by asteroid and meteorite impacts over billions of years. With virtually no atmosphere to protect its surface, Mercury bakes at over 400 degrees Celsius in the day and freezes at minus 183 at night. Venus proved even more inhospitable. In the 60s and 70s, both the Soviet Union and America raced to find out what was hidden below the thick layer of clouds. Armored like a tank, the Soviet Venera 9 survived the descent through the sulfuric acid clouds just long enough to transmit a picture of its base sitting on the scorched rocky surface. In the 80s and 90s, orbiting spacecraft used radar to penetrate the acid clouds and map the surface in detail. Without even setting foot on the planet, scientists had seen a landscape beyond their wildest imagination. Its surface is littered with volcanic cones and lava flows. The temperature on the surface of Venus is hot enough to melt lead. The atmospheric pressure is so great it would crush a tin can. It's unlikely that we would ever want to set foot here. It may be well into the 21st century before we can visit even the more hospitable of the planets. For most planetary scientists, the best method of trying to understand what conditions are like on the surface of other planets is to compare them with the similar terrain here on Earth. Our planet is peppered with volcanic structures, features that can help to unravel the mysteries of distant worlds. For John Spencer from the Lowell Observatory in Flagstaff, Arizona, this flight over his local volcanic lava field is like flying over Venus or Mars.
We're now looking at another absolutely gorgeous example of a cinder cone and a lava flow. You can see the crater in the center and big pile of cinders around the outside, and then coming out here at the base and spreading out for several miles is a thick lava flow going to other planets where all we can really see is the shape. We can't go down on the surface and sample the rock. We can still tell what the composition of the volcanoes is and something about their history just by looking at their shapes.
This group of recently active volcanoes in northern Arizona has spewed dark basaltic lavas from beneath the Earth's crust onto the surface.
Seeing lava flows coming away from craters like this is a surefire sign that we're looking at volcanic activity, whether we see it here on the Earth or whether we're seeing it elsewhere in the solar system.
Volcanoes help create the oceans and our atmosphere. If we can find volcanic structures like this on Mars, we can speculate that once it may have looked more like Earth. When the first spacecraft flew past Mars, the evidence for volcanic activity was unequivocal. Images beamed back revealed structures very similar to those the scientists could see on Earth. These cones are thought to be dead now, but the evidence of an active past is everywhere. Mars boasts the largest volcanoes in the solar system. This is Valles Marineris, the largest rift in the solar system. If it were here on Earth, it would stretch across the Atlantic. It's a giant scar, evidence of a dynamic past when the Martian crust was torn apart. This is the Jet Propulsion Laboratory at Pasadena, California, home of NASA's unmanned space missions. The task of getting the first mobile rover to land safely onto the surface of Mars was the responsibility of JPL's Rob Manning. Manning and his colleagues had spent years designing and building a new robotic rover called Sojourner. It would be the first vehicle that NASA had landed on another planet for over 2 decades.
Going to Mars for the first time in 20 years was a challenge because a lot of the people who knew how to go to Mars and land on Mars were dead or retired. So we had to go back to the drawing boards and really figure out again from first principles how to bring a lander to another planet.
Manning's young team decided on a radical new way to land. To save money, Sojourner would be dropped down onto Mars inside inflatable airbags.
Engine start 1-0 and liftoff of the Delta rocket with Mars Pathfinder, and the vehicle has cleared the tower.
After a 7-month flight, the Pathfinder mission made its final approach. Manning and his team were about to discover if their unique method of landing would work.
The next event is lander separation. That should occur in about 5 seconds.
Sojourner rocketed down through the thin Martian atmosphere and survived at least 15 bone-jarring bounces. Sojourner had come to a stop precisely on target. Years of hard work had paid off. For Manning, it was a moment of pure ecstasy. For the first time in a generation, NASA had returned to Mars.
Once the pedals opened up, and the next day, when we finally got Sojourner to stand up and roll down the ramps, for the first time, we had a mobile robot, a mobile laboratory, a mobile geologist that go out and explore another planet.
For the men and women who drove Sojourner from tens of millions of miles away, this was the next best thing to being there.
Operating your rover and lander on another planet, it feels like an extension of yourself. You really feel that you are there. Every day when we came to work, we went to Mars and we saw it for ourselves. It felt like an extension of our hands and eyes. And so it was very exciting. We knew what that landing site felt like to be there.
The Pathfinder mission had landed Sojourner in an area thought to be an ancient floodplain. As it roamed the surface for 84 days, it examined the boulders and discovered that Mars was covered with many different types of volcanic rocks. In 2003, NASA plans one of their most spectacular of all missions. This flight will happen exactly 100 years after the Wright brothers flew their first plane on Earth. The Mars airplane will fly to the most inaccessible regions where life might have existed and photograph them from the air. But for some people, robotic explorers aren't enough. They believe that true exploration can only be made by humans.
Have you ever seen a robot have a ticker tape parade in New York City? No. That's the big difference. We must go. It's within us to go. The question we ask about what is it like, what does it feel like, what does it look like, are questions people can relate to only through a human being, not through a robot, not through a camera, not through a computer chip.
As early as 2020, there might be a manned mission to Mars, the first to carry humans to another planet. Traveling to Mars will be a huge risk. It will take 9 months just to fly there, a round trip of at least a year and a half.
We will settle Mars. We will live there. It's a sister planet. It's there. It's beckoning our call. And we will inhabit it very much like we inhabit the Earth. And I can't tell you why or how quickly. People are going to say, what about water? What about... It's all there. All we've got to do is go find it and make it happen.
Carolyn Porco is a planetary scientist whose professional career has coincided with the modern era of planetary exploration. She's devoted her life to the giant outer planets that lie beyond Mars.
No matter how you cut it, the vast majority of our solar system exists out beyond the orbits of the asteroids. Inside, you have 4 measly little terrestrial planets, Mercury, Venus, Earth, and Mars. And while they're very important to us, especially the third one, most of the solar system is way beyond us.
In 1977, 2 identical Voyager spacecraft were launched to Jupiter on a path that would then catapult them onto Saturn. It was a now or never opportunity that took advantage of an alignment of the outer planets that only happens once every 176 years. Voyager 1 was spun out of the plane of the solar system, but Voyager 2 was flung on towards Uranus and Neptune. Voyager 2 sailed past Uranus at 40,000 miles per hour. It made its final rendezvous with Neptune after traveling over 4 billion miles. The Voyager spacecraft were the most sophisticated machines of their time. Their cameras would electronically record pictures, and their large white dishes beamed them back. The scientists knew that one day their spacecraft would fly beyond the solar system. They were keen to include a message for any curious aliens. Gold-plated LPs with greetings from every nation on Earth were bolted onto the spacecraft. They came complete with instructions and a stylus.
As the Secretary General of the United Nations, an organization of 147 member states, I send greetings on behalf of the people of our planet.
Silama Khemen, Oitnis Podeste Khairete.
Paz e felicidade a todos.
各位好嘛，祝各位平安健康快樂。
Adanish Lushulmu.
ขอส่งมิตรจิตมาถึงท่านทุกคน
Hello from the children of planet Earth.
2 years after launch, Voyager approached Jupiter. It recorded this remarkable time-lapse image of the king of the planets spinning on its axis. Hard to believe that this giant gas bag could swallow more than 1,300 Earths. Jupiter's 4 largest moons, Ganymede, Callisto, Europa and Io, were clearly visible as they orbited the planet. Here, circling the largest planet, was an entire planetary system in miniature.
I was one of those people standing in front of the monitors watching these images come down for the first time. Things we had never ever seen. People were lost for words. Very intelligent, bright people who'd studied planets their whole lives were lost for words. You know, I had the impression of being on the bow of a ship and, you know, entering uncharted territories and discovering things that no human had ever seen before.
Strangest of all were Jupiter's cloud tops. Here in intricate detail was the fearsome beauty of the Great Red Spot, a hurricane twice the size of the Earth, for some unfathomable reason has been raging for more than 300 years. Jupiter spins so fast that with a day less than 10 hours long, its clouds are drawn into streaks around the planet. Unlike Earth, its multicolored clouds are not powered by the sun. These storms of liquid marble are fueled by heat inside the planet. A childhood fascination with the king of the planets set amateur astronomer David Levy on a path that would help him discover a comet and predict Jupiter's most dangerous moment.
Well, I've been fascinated with Jupiter since the summer of 1960. That summer, I had my first telescope, and with my parents, I went outside, set it up, and looked up at the sky and saw the brightest star in the whole sky. Had 4 little moons and little bands across it, and I said, hey, that's Jupiter. It's the first thing I ever looked at through a telescope. And I think if that particular night, if my dad had said, you know, in 35 years from now, a comet with your name on it is going to go smashing into that planet, I would have been pretty surprised.
In 1993, David Levy helped discover an icy juggernaut that had roamed the back streets of the solar system for over 4 billion years. But Comet Shoemaker-Levy number 9 hadn't reckoned on the mighty gravitational power of Jupiter. The broken fragments were being sucked in by the largest planet in the solar system. Like bombers in formation, Shoemaker-Levy 9 made its final approach. The fragments plummeted down through the endless atmosphere. On the 16th of July, 1994, the astronomers back on Earth watched the mighty flare as the first fragments smashed into Jupiter. The titanic collisions left a series of massive scars across the planet.
Jupiter is the solar system's vacuum cleaner. If Jupiter weren't there, those comets would still be running around, smashing into all of the inner planets, including the Earth. The Earth would be being hit by comets instead of once every 100,000 years, might be being hit every 100 years or every 1,000 years. And we couldn't be here. We couldn't live on an Earth that was being smashed by a comet every 1,000 years.
But it was Jupiter's moons that held the greatest surprise. When Voyager turned its cameras on the innermost moon, Io, it revealed the most active and dynamic body in our solar system.
At the time of the Voyager flybys of Io back in 1979, we got our first close-up pictures of Io from the spacecraft as it flew past. And one of the engineers saw these sort of weird clouds and were not at all able to figure out what this was, but eventually decided that this had to be something real. It had to be volcanoes that were blasting material off of Io.
For Earth-bound scientists like John Spencer, one way to interpret what the volcanoes on Io are made of is to compare them to similar volcanic structures we can see here on Earth. These fresh lavas are made of basalt. The shape of these flows bear an uncanny resemblance to features that Spencer has studied on the surface of Io. Since Voyager, later missions have photographed this festering world in even greater detail. Spencer believes that the volcanoes of Io seem to have erupted the same black lava we can find on Earth. Io is only the size of Earth's moon, yet its largest volcanoes are hundreds of miles across. Because of the low gravity, they spew lava hundreds of miles above Io's surface. Io's close proximity to its parent planet Jupiter exacts a heavy price. As Io orbits around, it's stretched and squeezed by the immense gravitational forces.
The reason there are volcanoes on Io is because Io is very close to Jupiter and it's distorted quite a lot by Jupiter's gravitational field. Sometimes it's closer to Jupiter, sometimes it's further away. And when it's closer, it's stretched out, and when it's further away, it relaxes. So continually, once every orbit, Io is being squeezed and deformed, and that just puts a lot of heat in the interior. And that heats up the interior to the point where you have volcanoes on the surface.
As Voyager left Io, it captured real moving images of the first active volcanoes we had ever seen beyond the Earth. Voyager's next port of call was Saturn. It had taken the two probes over 3 years to reach here. Even from Earth, the rings are clearly visible, but Voyager discovered that they were wafer thin. They're composed of millions of separate rings, each made of countless fragments of rock and ice. Above them hover strange dark shadows, thought to be grains of dust swarming in Saturn's powerful electromagnetic fields. Slightly smaller than Jupiter, Saturn is still 750 times bigger than Earth. And like Jupiter, it's orbited by its own mini-planetary system of moons. Mimas, Rhea, Dione, with a count of over 18 moons, Saturn has the most moons of all the planets. The Voyagers were only able to spend a few precious hours photographing Saturn and its moons in detail. Carolyn Porco and her colleagues recently videoed their last farewell to a new probe to Saturn, Cassini. They had spent years designing a machine that will spend the rest of its life endlessly orbiting and photographing Saturn.
Cassini will be, once it pulls into orbit around Saturn, will be the farthest outpost that humans have ever dispatched in the solar system. And it will be the closest look at what still is for us a very exotic environment.
6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. We have cleared the tower. Pitch program is in. Roll program is in.
Cassini, this spacecraft that many of us had spent 7 years of our lives working on, designing and building, to see it get launched atop this gleaming white rocket, which rose from the launch pad, and it made this beautiful sweeping arc across the eastern sky, and then it was gone. I mean, it was literally gone. It left the Earth.
Stand by for solid rocket booster separation at 2 minutes. And the Cassini spacecraft is on its way to Saturn.
Named after the 17th century astronomer who first discovered a gap in Saturn's rings, the Cassini probe will arrive in July 2004. Cassini will also visit the largest of Saturn's moons, Titan. This orange orb is wrapped in a thick atmosphere. What lies below is anyone's guess. But there are tantalizing hints its surface may be covered with oceans of methane, crammed with the building blocks of life. Cassini will target and release the Huygens probe towards Titan. This probe is built to withstand landing on either an ocean or solid land. It will transmit back any signs of organic molecules from this unknown world. Voyager 2 reached Uranus early in 1986. It was 9 years since it had left the Earth. Uranus is colored blue because its atmosphere contains traces of methane. It's a featureless, cold world. But Uranus is different from all the rest. It rolls around the sun, spinning on its side, possibly because of a giant impact in its early life. Uranus is encircled by at least 11 incredibly thin rings of ice and dust, which Voyager showed us clearly for the first time. Last of the gas giants was Neptune, a giant blue sphere 2.8 billion miles from Earth. It was August 1989. Voyager had taken 12 years to reach here. It's so far out that it takes Neptune 165 years to orbit the Sun. It was remarkable that Voyager could photograph Neptune at all. Out here, the sunlight is only 1,000th as strong as it is on Earth. Like Jupiter, there is no solid surface. It's all gas, covered in layers of storm clouds. These are the fiercest storms in the solar system. The winds blow across the surface of Neptune at 1,400 miles an hour. Voyager's final task was to visit Neptune's largest moon, Triton. Across its surface were a field of ice volcanoes, where dark frozen nitrogen had spewed out onto the surface from underground. Our solar system had saved up its most bizarre object till last. Its task completed, Voyager left Neptune behind, hanging in cold, dark, empty space. It wasn't until the launch of the Hubble Space Telescope, above the Earth's atmosphere, that we could get a clear view of the furthest planet in our solar system. Hubble gave us our first view of this icy planet and its moon Charon. Pluto is officially the 9th and last planet of our solar system. But recent research suggests that it might not be a true planet at all, but one of hundreds of thousands of icy worlds orbiting in a belt beyond the edge of the solar system. Pluto and its numerous cousins form a belt of debris that are the leftovers from the birth of our solar system 4.5 billion years ago. Planetary astronomer Richard Tyrrell decided that if he could find similar large disks of debris orbiting around distant stars, it might provide evidence that other planets were being created inside our galaxy. At the Canada-France-Hawaii telescope on the summit of Mauna Kea in Hawaii, Tyrrell is successfully searching for new planetary systems orbiting around stars similar to our own sun.
We're now finding morphology, very, very exciting structure within these disks. We're seeing rings, we're seeing cleared out gaps. All of these are real indicators that these disks not only are associated with planetary formation, but may even signal to us that planets have formed around these other stars.
After more than a decade of searching, Tyrrell has now discovered 6 disks orbiting around new, young stars. For the first time, even the skeptics realize that our galaxy may be teeming with other solar systems, full of planets just like our own.
Most young stars will have these disks, which probably means that most stars have gone through the process which could lead, or probably leads, to planet formation. This is a tremendously important idea and leads to the conclusion that perhaps the majority of stars we see in the night sky, the majority of stars in our galaxy, contain planets.
The opportunities for discovering new planets will be endless. Future generations will be able to travel beyond the edge of our solar system and conquer billions of new worlds.
As we discover more planets around more suns in other galaxies somewhere out there in space, it's inevitable, as much so as me walking on a moon, that we will someday walk on those other planets.
Well, I think as human beings, we're always looking to explore the next horizon. And now that we've explored our planet, now we look up to the sky.
I know there are tremendous engineering challenges, and it won't be in my lifetime or, our children's lifetime, but eventually we will do it because we are designed to explore.
Quite literally, there are more stars in our universe than there are grains of sand on every beach on Earth. If you run your fingers through the sands on the beach and try to imagine just one of them being painted blue to represent the Earth and life on Earth, you'd have to be insane to think we're the only ones here.
At the start of a new millennium, we're about to embark on the greatest adventure of all time. 500 million miles from Earth, a spacecraft will land on Jupiter's icy moon, Europa. Its mission? To search for alien life. As we reach out across the galaxy, our spacecraft will explore the most extreme environments to answer the ultimate question. Are we alone? Our universe is made up of countless galaxies, each teeming with billions of stars like our sun. Orbiting around them may be billions of planets. Any Earth-like planet could be home to an intelligent alien trying to communicate with us.
The Pentagon admitted just moments ago that a researcher at the SETI Institute in California has detected a radio signal from beyond the solar system.
Il segnale captato al Deep Space Network di Madrid sembra provenire da extraterrestri. Gli scienziati
首脑将在今天召开紧急会议，商讨是否需要宣布各国进入紧急状态。这次汇集世界领导。
signal was first detected at 3 a.m. this morning, and following confirmation from other radio telescope sites around the globe, the Pentagon announced that the extraterrestrial radio signal should be considered valid.
There are 400 billion stars in our Milky Way galaxy and billions of other galaxies as well. It would be bizarre if we were the only life.
We're discovering that life forms can exist in places and conditions that we couldn't have conceived of a few years ago.
Since a good proportion of stars seem to have planets, we might expect primitive life to be widespread in the universe.
Scientists from around the globe are being asked to verify the exact origin of the signal.
What if we get a signal? What will happen? Will you still go to work tomorrow, or will the world stop? It's the oldest unanswered question that our species has posed to itself. Is anybody else out there?
It's a question that Jill Tarter has been trying to answer for over 20 years at the SETI Institute, an agency dedicated to the search for extraterrestrial intelligence. All over the world, SETI researchers are more optimistic about picking up that first call from ET than ever before.
What's so terrific about now is the fact that we suddenly have the technology that allows scientists and engineers to try and answer this old question. For me, I can't imagine doing anything more important.
Set amongst the dense rainforests of Puerto Rico is the largest electronic ear on Earth. It's so sensitive it could pick up a mobile phone on Jupiter. The Arecibo radio dish is 1,000 feet across. Twice a year, The SETI researchers come to Arecibo to listen out for signals from deep space. "5,000 miles away across the Atlantic is the Lovell Dish at Jodrell Bank. This is the largest radio telescope in Britain.
The equipment we're using for this search is the most sophisticated that's ever been used. It's using two of the world's largest radio telescopes to make the most sensitive system that mankind has ever been able to use, or probably will be able to do for 10 or 20 years in the future.
Together, these two dishes are targeting those distant stars most likely to be orbited by planets. They're trying to detect alien interstellar messages. But where on the radio dial will the extraterrestrials be broadcasting? The SETI Institute is currently scanning 28 million radio frequencies.
Talking about eavesdropping on aliens makes for easy dinner table conversation. In fact, doing it is quite hard. If you have 28 million channels, you can't just have 28 million guys with earphones awaiting the signal. You have to have very specialized computers that can look through all those channels at least once a second and make decisions about, is there something interesting in there?
Their computers isolate any unusual signals from the constant background radio noise that swamps the Earth from every corner of space. They're listening out for a special signal, one that suggests it's been sent by intelligent life.
You can imagine tuning the radio dial there and you'd hear this whoosh all across it due to natural noise sources. Not very interesting. But every now and again, you could imagine coming across a squeal. That squeal is called a narrowband signal. That's exactly what we're looking for, because only a transmitter, something that's been fabricated, can make a signal that's narrowband.
The researchers have to make sure the signal really is coming from deep space. They must eliminate any transmissions from passing aircraft, satellite, or military radar. It's only by using two dishes so far apart that they can calculate if the signal originates from beyond our solar system. This method has already picked out one distant signal. Though this isn't from ET, it's from one of our own interstellar spacecraft. In 1972, Pioneer 10 was launched on an epic journey to the giant planet Jupiter. Its mission long since over, Pioneer is now billions of miles beyond our solar system, but its signal is still loud and clear.
Pioneer 10 serves as a test case for us. In fact, it's so far away that its signal looks like a signal coming from a distant star.
Every day, the American and the British teams tune into the Pioneer signal. It's the most distant message they've ever received, but the scientists hope for something far better.
Have we ever found a signal from space that was clearly due to extraterrestrial broadcasters? Well, the answer is no. I mean, I wouldn't be sitting here if the answer weren't no. I'd be relaxing on the Côte d'Azur having a drink, I'm sure. We haven't found them yet. So far, the aliens have been coy.
Jill Tarter and Seth Shostak have both dedicated their lives to listening out for a message they may never receive.
Every day when we go to the telescope, we have some sense of anticipation that we may, in fact, find the signal. We put champagne on ice in the refrigerator here and wherever we observe, because we do plan for success.
The cosmic odds are stacked in their favor, and improving with every new astronomical discovery. There's no shortage of places a message might come from. Our own galaxy, the Milky Way, contains over 100 billion stars. stars. If every one of those stars were a grain of salt, they would fill an Olympic-sized swimming pool. How many of these stars have planets that could be home to an alien intelligence? Until recently, we could only guess. But over the last 5 years, astronomers have made an extraordinary breakthrough. They've discovered over 20 planets outside our solar system, and they believe there may be literally billions more.
My guess would be that something like 50% of all the stars in our Milky Way galaxy, which itself contains 100 billion stars, probably something like 50% of them harbor planets.
Jeff Marcy is one of the world's most successful planet hunters. He and his colleagues have discovered more planets orbiting around other stars than orbit within our own solar system. Standing high on the summit of an extinct Hawaiian volcano, the giant Keck telescope is Marcy's most penetrating eye on the universe. In 1999, his team made their most startling discovery. This time, they found not just a single planet, but 3 worlds orbiting the same star, Upsilon Andromedae.
We have found now a complete system of planets, just like the system of planets we have around the Sun. These are not isolated freak planets that we had been finding, but at least in this one case, we now realize there's a complete system that is very reminiscent of the ordering of the planets around our Sun.
This new planetary system lies 320 million miles from Earth. The closest planet whirls round its star in just 4 days, the outermost in 4 years. So far, their equipment can only pick out the real heavyweights, planets the size of Jupiter. But the planet hunters are convinced there's greater treasure to be found.
There's almost no question that among the 100 billion stars in our Milky Way galaxy, there are not just the large planets that we've been finding, but of course smaller ones, probably indeed in greater numbers. And so Earth-like planets are out there.
NASA's proposed Kepler mission may provide the definitive proof of Earth-like planets. In the early part of the 21st century, this space telescope will continuously monitor 160,000 stars. Kepler's eagle eye will watch for any star that blinks, even when a planet as small as Earth passes in front of it. But if we do find an Earth-like planet, there's no guarantee it will be home to intelligent aliens. It may be too hot, too cold, or too poisonous for ET to survive. Or perhaps alien life may have evolved on planets where the conditions would be far too inhospitable for humans. To find out just how extreme an environment can be and still sustain life, NASA is researching the most hostile places on Earth. Before we set out to look for life on other planets, this research will direct us where to look. NASA scientist Tony Phillips is searching for primitive life in one of the coldest places in North America, high in the eastern Sierras.
Right now we're at the White Mountain Summit. We're at an altitude of over 14,000 feet. The pressure here is very low. During the wintertime, the temperature here is comparable to the temperature at the South Pole during the South Polar summer. So the environment is very extreme. Not much lives here, but we suspect that there may be microorganisms living in the soil or living in the permafrost beneath the layer of rock, and no one knows whether they do or not, but that's what we're trying to find out.
Hike, Tovik, hike! Whoa, 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 hang on, guys.
The NASA scientists have discovered that life can survive in places where no one had expected. It now turns out that life can survive just about anywhere that there is water. It doesn't seem to matter how hostile the environment is. At Yellowstone Hot Springs in Wyoming, Dave D. Murray has proved that microbial life can even survive in boiling water, an extreme environment that we never thought possible before.
The limits for life are much broader than we had previously suspected. We've now discovered that life can exist up to 113 degrees centigrade, a higher temperature than we had dreamed about 20 years ago. But we find that that is actually a very nice place for certain organisms to live.
If life can survive at these temperatures, perhaps it can live anywhere. Mono Lake in California is one of the most hostile environments on Earth. Its scenic beauty is deceptive. The lake is so loaded with salt that it's poisonous to us. Jack Farmer has discovered that even here, life can find a way.
In Mono Lake, the salinity of the water here is 2.5 to 3 times seawater. In addition, the pH of the water here is around 10.5, very alkaline. And yet, that's not a barrier to life. Organisms are thriving here.
The lake is teeming with microbial life.
In the last decade or so, we've begun to realize that it's really a microbial world. This world that we live in is dominated by microorganisms. We've come to realize that microbial life can occupy a whole range of environments that we never thought possible before.
The tenacity of life here in Earth's most extreme environments encourages many biologists to believe that life may be remarkably widespread throughout the universe.
I think the chances of finding life elsewhere in our solar system are pretty good. Sometimes I say, well, maybe 50-50, but I have to be honest, I don't really know how to put a probability on it. But I think anywhere where we had liquid water and the right organic compounds present, we've certainly had more than enough time to originate biological systems. The probability is probably pretty good.
For most of Earth's history, the only living things were microbes. As they search the universe, scientists expect to find planets crawling with microbial life long before they find one with intelligent life. Instead of meeting little green men, they're much more likely to meet little green slime. Our quest to discover life on other worlds began optimistically in the 1960s when a flotilla of spacecraft headed for our neighboring planet, Mars. But their cameras revealed only craters and extinct volcanoes. Mars seemed a barren and lifeless world. This gloomy assessment was reinforced in 1976 when 2 Viking craft landed on the rocky Martian surface. They scooped up soil samples and analyzed them for any signs of microbial life. The results were negative. Mars seems extremely hostile to life. The average temperature is minus 53 degrees Celsius, and the thin atmosphere provides no barrier to the sun's deadly ultraviolet rays. Even the rocks contain chemicals that can destroy living cells. But the idea of finding life on Mars continues to obsess many scientists. When Bruce Joukowsky started his research career, Viking had just landed.
Viking went, it looked for life, it found none. And there was a real sense that there must be only one planet in our solar system that could support life, and that was the Earth. Things have changed dramatically since then, in particular, the revolutions in terrestrial biology and the possibility that life could have originated in some of these extreme environments.
Close-up pictures of the red planet have revealed tantalizing evidence that water once flowed across the surface of Mars.
We see clear geological evidence that there's been water on Mars. On some of the older surfaces, we see networks of valleys that look like river tributary systems where waters flowed through them and carved these long channels. The availability of water at the surface or in the crust really, I think, is what makes it possible for life to be there.
The evidence came sooner than expected. On August the 7th, 1996, NASA called an unprecedented news conference. These scientists had examined a meteorite that had come from Mars and discovered something very strange lurking inside. One of the microbiologists on the team was Dave McKay.
We have a number of forms which it is very tempting for us to interpret as Martian microfossils.
The NASA team had been alerted by chemical residues in the rock that here on Earth can only be made by microbes. Then they picked out strange worm-like structures that looked like tiny fossilized life forms. It all began with a unique discovery on the snowy wastes of Antarctica. Each year, a meteorite survey team sets off across the Antarctic ice cap. Meteorites fall all over the Earth, but here the small dark rocks are easy to spot on the pure white ice. In 1984, the team picked up one meteorite, ALH 84001, that was to completely change our view of life in the universe. It wasn't until 9 years later that researchers discovered that the survey team had brought back a lump of Mars, a rock formed 4.5 billion years ago. Its origin was proved by traces of gas which exactly matched the composition of the Martian atmosphere measured by the Viking landers.
This is an incredibly complex rock. It's much more complex than we first realized. It's more complex than most Earth rocks that people study. And this rock has been studied more than any rock in the history of the world.
Some scientists believe the microscopic structures are natural crystals, but for McKay, the case for Martian life grows ever stronger.
These are fossils of little tiny bacteria, single-cell organisms. They're not bones. They're little tiny cells that have turned to minerals. They're fossilized, but they look exactly like fossils from Earth rocks.
But the only way to find out for certain if there's ever been life on Mars is to go there and collect a sample. NASA missions in 2003 and 2005 will collect rocks from the Red Planet and then return them to Earth, where they'll be dissected for fossils. The surface of Mars is the same area as all the continents of Earth combined. There's an enormous choice of possible sites when it comes to collecting the priceless samples. Mojave Desert in California is one of the most inhospitable places on Earth. This dry lake bed was once covered in water. Its parched surface is the perfect place for Chris McKay to research where NASA should collect its first samples in order to look for fossils of microbes that once lived on Mars.
This lake bed is the sort of place we'd be looking for on Mars, as a place to search for evidence of past life. It's a nice, big, easy-to-find target, easy to land in, easy to drive around on, easy to drill in. If there had been water in a lake like this on Mars, anything living in it, as it died, would settle to the bottom and we'd be able to find it in the sediments. Here in the Mojave Desert, we might dig under the surface and find evidence of life that's just a few years old. But on Mars, these sediments would be 3.5 to 4 billion years old, and we'd be looking for evidence of life that was on that planet when it was more like the Earth, when it had water. Here in this desert, we find, growing just underneath the surface of certain rocks, microorganisms, algae. These organisms grow under the rocks because the rocks trap a little bit of moisture, so it's not quite as dry. But they have to grow under the white stones because enough light can get through the white stones so they can photosynthesize.
This precarious existence could have been the way that life on Mars survived for billions of years.
Who would have been the last organism to live on Mars? Maybe an organism living underneath a rock. Maybe when we go to Mars, we'll search for relics, for fossils of this type of life.
But perhaps the search will turn up much more than just fossils. Despite the barren landscape, some biologists are now uttering what was for many years a heresy: that microbes may still be living on Mars today. Microbiologist Todd Stevens has discovered that deep underground in Washington state, life is flourishing in apparently solid rock. Until the mid-1980s, most people thought that the deepest you could dig down into the ground and find living organisms was around 30 feet. But Stevens has discovered that life on Earth can thrive as deep as 2 miles down. The Columbia River area of Washington state is covered in ancient lava flows thousands of feet thick. At the edge of a river gorge where the lava flows are exposed, Stevens has discovered how tiny microorganisms can live in solid rock.
Here at the bottom of the canyon, we can kind of get an idea of what their habitat looks like. Here we have the intersection between 2 basalt flows, and at one time water has flowed through this layer over tens of thousands of years, and microorganisms live here. Well, this is exciting because if this is correct, this is a way that living organisms can live in places where the surface of the planet is not habitable.
On Mars, any microbes living deep in the rock would be well protected from the hostile surface environment. Stevens was researching the safe disposal of nuclear waste when he made his startling discovery about life deep underground.
This one has to be several hundred meters deep in water.
He took water samples here from boreholes that were drilled 2 miles down through the volcanic rock.
When we sampled the water that was coming out of the deep aquifers in this volcanic rock, we were kind of surprised to find that each liter of water contained between 1 million and 100 million microbial cells. And we know that the vast majority are actually attached to the rock, so there's many more than that down there.
To prove they could survive without sunlight, Stevens bred the microbes in his laboratory, simulating their subterranean world. His results confirmed life's amazing ability to live anywhere there's water. These bacteria, stained red, feed off hydrogen gas, created when water reacts with the volcanic rock. Even more exciting, these bacteria bear striking resemblance to the apparent fossils found in the Mars meteorite. Perhaps the descendants of these fossilized microbes are still living deep under the Martian surface. The temperature on Mars is well below freezing. Any life near the surface would be frozen solid. Astrophysicist Richard Hoover has made the astonishing discovery that microbial life can be reanimated even after it's been frozen for thousands of years. The Fox Tunnel in Alaska is one of the coldest places on Earth. It was originally excavated for gold mining and dug out of the permafrost, where even the soil 150 feet below the surface is frozen solid.
We have found microorganisms in the permafrost of Earth that are alive, and yet they have been frozen for up to 3 million years. Therefore, it is possible that there may be microorganisms frozen in the permafrost of Mars.
By warming samples from the permafrost, Hoover can revive these dormant organisms. It's not just microbes that wake up when the temperature rises. Even plants like moss can be brought back to life.
I have here a moss that was frozen in the permafrost for 40,000 years, and after it was extracted from the permafrost, the moss started to grow. It realized that the weather had gotten better and it was time to grow again.
As they're warmed up, any samples of life collected from Mars by NASA may also be revived. Returning a piece of Mars to Earth will require the strictest quarantine. It may be the most risky venture the human race has ever undertaken. No one knows what might happen if Martian bugs were released onto our planet.
If there's life on Mars, we have to be cautious because that life is not understood. And as we know, microbial life can be quite dangerous. Both viruses and bacteria can be dangerous to humans. It can also hurt the environment.
Unlike the meteorites, which have been sterilized by natural radiation as they travel through space, these rocks will have been transported directly from Mars.
They will be treated as if they might have an incredibly dangerous microbe in them. We don't know that, we don't think that'll be true, but we can't afford to take the chance.
4, 3, 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
In 1989, Space Shuttle Atlantis set off on a mission that may lead us to the first definitive discovery of life beyond our own planet. On board was the unmanned Galileo spacecraft, bound for the king of the planets, Jupiter. In this remote frozen region, 500 million miles from the sun, the last thing the mission scientists were expecting to find was signs of life. Giant Jupiter is big enough to swallow the Earth 1,000 times over. Its family of moons forms a miniature solar system. The four biggest are Io, Ganymede, Callisto, and Europa. Brilliant white Europa is completely covered in ice, its surface crisscrossed by strange grooves. Many scientists now believe that this frozen world is the most likely place in our solar system to be harboring extraterrestrial life. The nearest equivalent to the surface of Europa are the glaciers of the Arctic.
The microorganisms that are found in the glaciers and in the polar ice caps give us a good model for the types of microorganisms that might be found someday when we bring back samples from Europa. I have become very excited when I look at the beautiful pictures of Galileo of the surface of Europa because we see magnificent colors. And those colors are very similar to colors that we see in bacteria and algae on Earth due to the pigments of these microorganisms. When we do get samples back, we will have a good idea of what types of things to look for, and we will have the ability to recognize the microorganisms when we find them.
The microbes of Europa would have to be far tougher than their Arctic counterparts. They'd have to survive lethal doses of radiation generated by Jupiter's powerful magnetism.
We know that there are microorganisms on Earth that have evolved to have the ability to withstand intense levels of radiation. There are bacteria that grow on the cooling rods of nuclear reactors. And if, in fact, organisms live on Europa, then they would have had the ability to adapt to these high radiation levels. So we must always be cautious about saying that life cannot do things because quite frequently we find that life does exactly what we think it's not capable of doing.
The cracked ice surface may suggest something even more exciting. Heat from the core of the moon may have melted the ice from below. Just like the cracked Arctic ice sheet on Earth, Europa's icy surface may overlie a huge ocean of water.
All life as we know it utterly depends on liquid water. Europa may be the only other place in the solar system where there's an ocean of water, and that means it's the most exciting place to go and look for life elsewhere.
Beneath the icy crust of Europa could lie an ocean as deep as 60 miles. This cold, dark environment seems a fruitless place to look for living organisms. But the depths of the Earth's oceans prove that life can once again flourish in the most unexpected places. In the 1970s, the lights and cameras of deep-diving submersibles discovered vents erupting hot water from the ocean floor. Where no sunlight ever penetrates, and the surrounding water verges on freezing, these volcanic vents support the most exotic life forms on Earth.
it's certainly possible that those sorts of hydrothermal vents exist on Europa. There may well be teeming communities of organisms at hydrothermal vents at the very bottom of Europa's oceans. Now, on Europa, that's 100 kilometers down. The oceans on Europa are much deeper than they are on Earth, so those are not going to be easy to reach and investigate.
Around 2010, NASA plans to send its most ambitious unmanned mission ever. Touching down where scientists suspect the ice is thinnest, the Europa lander will lower a probe that melts down through several miles of ice. A second probe, a hydrobot, will swim down to the bottom of the ocean. As it descends, it will transmit live pictures back to Earth. The hydrobot will be programmed to seek out hydrothermal vents, the most likely place to find life. This will be the most alien environment we have ever explored. Will it be teeming with tiny microbes? Or perhaps home to fully developed alien creatures? Even if we do discover life in our solar system, scientists believe that it will be fairly primitive. If we want to find complex life forms like us, we'll have to look far beyond our neighboring planets.
If we want to think about intelligent life, we need to look past our solar system. We need to look at the possibility of Earth-like planets orbiting other stars and whether life might have originated there. And then we need to think about communicating with them.
Any nearby aliens would already know that we are here. For the last 75 years, Earth has been leaking radio and television transmissions out into space.
Tracking the sound.
Our broadcasts reach the nearest stars 4 years after they are transmitted on Earth.
Eagle has landed. Marilyn Monroe was found dead under circumstances that were in tragic contrast.
Our oldest signals, broadcast in the 1920s, have traveled past 100,000 stars in our galaxy.
The Hindenburg horrible end has shocked the entire world. The pride of the skies equals its
Beyond this point, 75 light years from Earth, no one would have any idea of our existence. Alien civilizations may be far older than the human race. Dan Wertheimer is pioneering a completely new approach to intercepting their interstellar messages.
We don't really know what other civilizations are going to be doing, so we ought to try a lot of different strategies and not put all our eggs in one basket. Perhaps other civilizations, instead of sending us radio waves, are sending us light waves, perhaps from very bright lasers.
Wertheimer is hoping to intercept laser-like messages that extraterrestrials are beaming across the universe. On Earth, we can produce laser-light signals 1 million times brighter than our sun. We have already transmitted our own laser beams to the moon and back. If we can do it, Wertheimer believes that ET can do it even better. Here at the Leuschner Observatory in California, his telescope is linked to a high-speed computer that's searching for a spike of a pure color of light, the telltale signature of a laser. Over the next few years, this telescope will scan 2,500 stars.
We're looking for a very bright pulse. It would only be on for perhaps a billionth of a second. It's like looking for the kind of flash that you'd see from a lighthouse. As the beam comes around, you'd see a sharp pulse, very bright, and then it would go off for a while, but then you might see it again.
Hidden in these short pulses could be a whole encyclopedia of information, coded like our own computers.
If they send us a signal intentionally, it's likely that they will make it easy for us to understand that message. It will have language lessons, lots of pictures, vocabulary lessons, and then they would send us a huge amount of information, all their music, their poetry, their literature, their science, their medicine. That would be an amazing feat.
It's an opinion that may be naive. The aliens could turn out to be worse than any science fiction nightmare.
I think it would be a disaster. The extraterrestrials would probably be far in advance of us.
Astrophysicist Stephen Hawking believes that not all aliens will be friendly. We should take heed of past experiences on Earth.
The history of advanced races meeting more primitive people on this planet is not very happy, and they were the same species. I think we should keep our heads low.
I don't think that other civilizations are going to come and eat us. There are not that many raw materials on Earth. There are much bigger planets. And also, I suspect that advanced civilizations are not killing each other the way we are.
But even if they are aggressive, the sheer size of the universe makes it unlikely that we will meet an extraterrestrial in person.
Imagine yourself as one of the crew of this faster-than-light spaceship of the future.
Hollywood and science fiction try to convince us that it's easy to travel to the stars faster than the speed of light. So far, the fastest we can manage in our current spacecraft is 40,000 miles per hour. At this rate, it would take 70,000 years to reach even the nearest stars. The only realistic way to make contact is to eavesdrop on alien signals. And we may be communicating with aliens sooner than we think.
I'm optimistic in the long run. Probably in our lifetimes, maybe 50 or 100 years, we will be in contact with other civilizations.
If we did find a signal, it's bound to have a fantastic effect on our human civilization. I don't think there'd be any worry or any panic, but we would know for the first time that other life exists.
We may find out that we are just one of many civilizations in the universe. Or we may find out, in the end, that we are extremely unique. So maybe we're alone, maybe we're not. Either way, the answer is really significant.